Hello and welcome friends, myself Dr. Smiley Pruthi. In this next video I'm going to take this topic, Pasteur's, Warburg's and Crabtree effect. There is quite a confusion between all these three, so I'll be clearing all the confusion. So let's get started. I'll be starting with the basics. In anaerobic glycolysis, from 1 glucose we can obtain 2 ATPs. This is the maximum ATP we can obtain in anaerobic conditions. But you know that in aerobic conditions, the complete breakdown of 1 glucose will give you maximum 32 ATPs. Can you see this difference? That in anaerobic condition we can just get 2 ATPs, but in aerobic conditions we can get 32 ATPs. So in aerobic conditions we can get 32 ATPs, but in anaerobic conditions we can get only 2 ATPs. Suppose it is anaerobic condition and I want 32 ATPs. Then how many glucose I have to use? Because 1 glucose gives 2 ATP. For making 32 ATPs, I have to use 16 glucose molecules to obtain 32 ATPs in anaerobic condition. So can you see it is wasting of glucose occurring, because 16 glucose molecules will be wasted to give 32 ATPs, which can be obtained by only 1 glucose if it is aerobic condition. So we can say that anaerobic glycolysis is wastage of glucose. Anaerobic glycolysis is wastage of glucose, that is 16 glucose molecules are wasted just to get 32 ATPs. Now what is Pasteur's effect? Pasteur's effect is an effect occurring in any normal cell of the body. It says that if oxygen is present, then anaerobic glycolysis is inhibited. Anaerobic glycolysis is inhibited. Why it is inhibited? You know, we have oxygen, we can obtain 32 ATPs from 1 glucose, then why to waste glucose in anaerobic glycolysis? You know, anaerobic glycolysis is wastage of glucose. So that's why this is a normal effect occurring in any normal cell of the body, that is known as Pasteur's effect, that whenever oxygen is present, then anaerobic will be inhibited, so that we can use glucose to obtain 32 ATPs by aerobic glycolysis. Now what is Warburg's effect? Warburg's effect. This effect is occurring in cancerous cells. It is a paradox from normal. It says that even if oxygen is present, glucose will be converted to lactate, and this is presence of oxygen means aerobic. Glucose to lactate formation means glycolysis. This is known as aerobic glycolysis. Don't get confused. It is just known as, like I will give you an example. See, removal of hydrogen is known as oxidation, right? Removal of hydrogen is known as oxidation. You know, addition of oxygen is also known as oxidation. So when removal of hydrogen is occurring, it is just known as oxidation. Otherwise, oxygen is not added to that compound, right? Just known as. Sometimes we do such things in theory that it is just known as, okay? So here also in Warburg's effect, it is known as aerobic glycolysis. It is a kind of glycolysis occurring in the presence of oxygen, so it is known as aerobic glycolysis. Normally in aerobic glycolysis, the end product is pyruvate, not lactate. Normally in aerobic glycolysis, you get 7 ATPs. But in this kind of aerobic glycolysis, which is occurring in cancerous cells in Warburg's effect, if they ask you how many ATPs are formed in this kind of aerobic glycolysis, then you will say 2 ATPs. What is the end product of this aerobic glycolysis? Then you will say lactate. Okay, so be careful here. And let me tell you, lactate is the dead end of glycolysis. Lactate is the dead end of glycolysis. So if lactate is formed in cancerous cells, after that link reaction TCA etc will not occur. So in short we can write about So in short, we can write about Warburg's effect that Warburg's effect is aerobic glycolysis and no oxidative phosphorylation, means this glucose is not entering into ETC in this cell, right? So from this knowledge, can I say that in cancerous cells, each glucose is just giving 2 ATPs? Whether oxygen present or not present, whatever be the scenario, Warburg's effect says that glucose is going to form lactate and only 2 ATPs will be getting from this glucose. So each glucose is just giving 2 ATPs. That means lots of glucose is to be used by cancerous cells, because cancerous cells have huge requirement of energy. They are growing at a rapid rate, so they are using lots of glucose molecules and they have high rate of glycolysis. That's why that weight loss of cancerous condition occurs, because each glucose is just giving very few ATPs, that is only 2 ATPs, and there's high energy requirement for cancerous cells, and all the glucose is diverted to the cancerous cells use. And cancerous cells are wasting glucose because they are converting glucose to lactate and taking out only 2 ATPs from each glucose. Now coming to the third effect here, Crabtree effect, which is least important, but I'm going to explain it here because some people have apprehension for this effect also. So see here, Crabtree effect, when oxygen supply is kept constant and glucose concentration is increased. When oxygen is kept constant and glucose is increased, then oxygen consumption by the cells fall. Why it happens? Because when glucose concentration is increased, then rate of glycolysis will be increased. There is one step in glycolysis, that is glyceraldehyde 3-phosphate dehydrogenase step. This enzyme uses inorganic phosphate, and after glycolysis ETC has to occur. ETC also uses inorganic phosphate. So here glyceraldehyde 3-phosphate dehydrogenase competes with ATC for that inorganic phosphate. When lots of glycolysis has occurred, then the amount of inorganic phosphate present in the cells is very less, that ETC cannot occur. So ETC uses oxygen. So we can say when ETC is not occurring, then oxygen consumption by cells fall. Now you can compare Pasteur's effect and Crabtree effect. They're exactly opposite to each other. See, Pasteur's effect, I told you that in the presence of oxygen, anaerobic glycolysis is inhibited, or we can say that in aerobic conditions, glucose utilization decreases, right? But what is Crabtree effect? That when oxygen supply is kept constant and glucose concentration is increased, then oxygen consumption by cell falls. Or we can say that if glucose increases, then oxygen consumption falls. So see here, Pasteur effect is in aerobic condition, that is when oxygen is present, then glucose utilization falls. But Crabtree effect says that if glucose increases, then oxygen consumption falls. So they are exactly opposite to each other. And Warburg and Crabtree effect have many things in common, but they are different. After reading the details, some people are confused that Warburg's effect and Crabtree effect, is it the same thing? No, it is not the same thing, because Warburg effect is found in cancerous cells and Crabtree effect is found in yeast cells, right? So their properties are same, but they are different. This is it with this topic. I hope my points are clear. Thanks for watching. Best wishes to you.